Greetings to all. This is Vaishnavi, Assistant Professor, IT Department from SNS College of Engineering. Now we are going to see about the multiprocessor scheduling, real-time scheduling and the algorithm evaluations in operating systems. First one, multiprocessor scheduling. It consists of more than one processor. Multiple CPUs share the load, that is load sharing in multiple processor scheduling, so that various processes can run simultaneously. Shares the common bus, memory and other peripheral devices. So we can say that the system is tightly coupled. These systems are used when we want to process the bulk amount of data, and these systems are mainly used in the satellite weather forecasting, etc. Next one, multiprocessor scheduling. In multiprocessor systems may be heterogeneous, that is different kinds of CPUs, or the homogeneous, that is same CPUs. There are two approaches to multiprocessor scheduling in the operating system, that is symmetric multiprocessing and asymmetric multiprocessing. Symmetric multiprocessing, if it is used where each process is self-scheduling, and then all the process may be in common ready queue, or each processor may have its private queue for the ready processes. The scheduling proceeds further by having the scheduler for each processor examine the ready queue and select the process to execute. Next one is asymmetric multiprocessing. It is used when all the scheduling decisions and input-output processing are handled by the single processor called master server. The other processor executes only the user code. This is simple and reduces the need for data sharing, and its scenario is called the asymmetric multiprocessing. Next one, real-time scheduling. The real-time computing is divided into two parts, that is hard real-time systems and the soft real-time systems. Hard real-time systems are required to complete the critical task within the guaranteed amount of time. The scheduler requires the process to declare its deadline requirement before it entering into the systems. Then it employs a technique known as admission control. That is, the process is admitted if the scheduler can ensure that it will be accomplished by its deadline. Otherwise, it is rejected. Soft real-time systems, the requirements are less strict. It is not mandatory to meet the deadline. A real-time process always gets priority over the other task and retains the priority until its completion. The implementation of the soft real-time system requires the following properties. Must employ the primitive property based on the scheduling. Real-time processes must be assigned the higher priority than the non-real-time processes. Priority must not be changed during its lifetime. Dispatch latency must be low. Next, we have that keep the dispatch latency low is to provide the primitive kernels, and then higher priority process requires the accessing the kernel data. Next one, higher priority process has to wait for the lower priority to complete their execution, and then priority inversion problems has to overcome the use of the priority inheritance protocol. Next one, algorithm evaluations. To select an algorithm, we must include the several measures such as maximize the CPU utilization under the constraint that the maximum response time is 1 second. Maximize the throughput such as turnaround time is linearly proportional to total execution. Next, different evaluation method. We have the 4 different evaluation method. First one is deterministic modeling. One major class of evaluation method are called analytic evaluation. Analytic algorithm uses the given algorithm and the system workload to produce the formula or the number that evaluates the performance of the algorithm that for the workload. Next one, queuing models. Queuing models, we have that formula n is equal to lambda x w. N is that average queue length and w is the average waiting time, and that Lambda is the average arrival rate. This equation is known as Little's formula. Next, third one is simulation. It is more accurate. Simulation involves the programming model of the computer systems. Trace tape is created by monitoring the real system, recording the sequence of actual events. Fourth one is implementation. This is the only completely accurate way to evaluate the scheduling algorithm is to code it, put it into the operating system and see how it works. The major difficulty is that cost of the approaches. A form of this method is used commonly for the new computer installations. Thank you.